everyone. My name is Amparo López and I am full professor at Universitat Politécnica de Valencia in Environmental and Engineering Department. Today we will be speaking about regulation in hydraulic pumps. Why do we need to regulate, to control flow and pressure across a particular facility? When we finish, we will be learning to understand this need of regulation in a system of a particular hydraulic pumps in real networks, and we will identify the ways to regulate this pressure and this flow across pumped distribution networks in real systems. So we will be speaking about the need of regulation, the operating curves, the performance of regulation, the way considering the set point curve, and the way considering the characteristics pump curve to finally conclude. So the first thing we will be speaking about is why we need regulating the pump systems. Well, the main objective of regulation is to adjust the operating point to a particular desired flow rate, because we need a particular flow rate, not a range of this. So this regulation must be done in a complex system, in any case, with the aim of maximizing the energy efficiency and accomplishing all the parameters required in the facility without cavitation. To do so, we must regulate with a combination of pumps in series or in parallel, because this is what we are using in our pumping station. So pumps are needed to provide the pressure and the flow, and we need to provide a system to control the operating point of the whole systems. So why do we need this regulation? To provide an operating response, a particular, to optimize the pump itself, to operate always as close of the set point curve, to maintain a secure supply in the case of a pump failure, and to limit flow rate variations in a real system. So what will we do? We will have two curves. One determining the installation, the facility, which is the set point curve. This is the minimum piezometric height required for the system to give flow to the most unfavorable intake points. And on the other side, we need to determine this a long time with different patterns of consumption. So we will need it to do with the minimum energy implications. On the other side, we have the pumps of the curves and the characteristics of these pumps, which are the characteristics curves representing flow versus pressure. This is the curve of the pumps or the pumps association in series or in parallel. So what we need to do is to have the particular operating flow that the particular facility is requiring. How will we do this? How can we get these needs with the minimum energy cost? We will be doing this across regulation. And to understand how regulated systems are performing, we have the performance of regulation, which relates the minimum power required by the system with the total absorbed power to see if we are near or far of the minimum requirements to see if we can improve the installation. So how can we do this? We can do it considering association of pipes with the installation. And this is not simple because our network is what it is, but we can do it considering valves in series and valves in parallel, which is easier to change. In this case, we change the set point curve. And we can do it on the other side by changing the pumps, the characteristics curves, considering association of pumps in series or in parallel, or considering variation in speed of the pumps with frequency converters which is simplest because we can choose, we can play with the velocity of the machine to achieve several operation points. So we speak about the necessity of to meet the system requirements and the pressure and flow conditions, and to do so with energy efficient manner, we need regulation. To do this, we must consider energy, power, and environmental implications, and we will be considering the performance of regulation. To do so, we must control the operating points, either changing the characteristic curve, either changing the set point curve, in terms of the best solution to have the best efficiency point and the best performance of regulation, which is our duty to select the regulation of the system. I hope this was of your interest. Thank you very much indeed.